Hello, my name is Jonathan. I'm going to be discussing the prototype that I designed for the Mechanical Engineering 2900 class at The Ohio State University. This is an introduction to design engineering. The prototype that I designed is a smart makeup mirror. The main components of the mirror are an internal battery, a power booster, a motion sensor, a RGB LED as an indicator, a photocell on the back, a capacitive touch LCD screen, a addressable strip of RGBW LEDs, and an accelerometer that are inside the mirror here. And then that is going to be all powered by an Arduino Nano for this project. Currently, the internal battery is plugged into this battery pack here, and we're charging the internal battery. The RGB LED here showing green shows that the internal battery is charged in the fully charged state. So the RGB LED has three modes. The first one being green, meaning the internal battery is fully charged and indicating that it's plugged into USB power. The second one, if this was orange, that would indicate that the battery internally is being charged. It's plugged into power, but it's not at full charge. And then red, meaning that the internal battery is not plugged into any sort of power source and it is low, indicating to the user that it's time to recharge the battery. And that just is off a little USB plug here that can be plugged into either a battery cell and or into the wall. The accelerometer in the head of this and the photocell are used to depict which orientation the mirror is. I'll show more about that in a minute. The motion sensor detects any sort of motion, and when that detection happens, it turns on the screen as well as the RGBW lights into a white only light. And the screen allows the user, you can touch the different modes down here for the dimmer, and you can change the brightness of the LEDs and or turn them off if you want to use the mirror without the LEDs. If you cover the photocell is detecting light in the room. The ambient light's too bright in here, so I'm going to cover that. And if we invert the mirror will go into a nightlight mode where it turns on the rest of the RGBW strip. And gives some cool colors here as a simple night light. It also turns off the LCD screen, so there's no inputs allowed from the user when it's in this mode. Also turns it off to save power, and it will just constantly run this cycle as a night light just for aesthetics. And then when we flip the light back over, we run back a standard white mode. Again, our screen comes back up and it remembers the last input from the user as far as the dimmer goes, to remember where the user had the brightness setting last. And then when the motion sensor does not detect any motion, but the mirror is in a standard mode like this, it will actually turn the screen off as well as the white lights off, as you can see here, to save power. And then when someone moves in front of it again, it will turn the lights back on and turn the screen back on and allow the user to continue to adjust the brightness settings. As I was stating before, this indicator here, that is driven from the Arduino Nano. The power booster that the battery cell is plugged into is monitored by the Arduino, and it's constantly monitoring those voltages to know if it's plugged into external power or not. The accelerometer in the head of this knows which position it's in, if it's oriented correctly or if it's inverted. If the photocell is taking in too much light, but it is inverted, it will still turn off the screen and it will still turn off the LEDs just to turn the mirror off into a power save mode. And then when the photocell is covered and the room is dark enough, it will go back into a nightlight mode, and at that point go through the color scheme again. So if we flip this back around, it will go back to the white light mode. Thanks for watching.